Okay guys, I'm making this video for those of you at home to talk about the loop and junction rule. Okay, so I have two different circuits here. Let me shift my screens a little bit, get that out of the way. Okay, so one is a series circuit, one is a parallel. I have three light bulbs in. They are not identical light bulbs though. If I were to click on each light bulb, alright, is it going to let me click? There it goes. Sorry, that one's 30 ohms, that one's 20, that one's 10. Same thing basically here, 30, 20, 10. Okay. So one of the things I want to point out obviously is, when you're looking at these in terms of the brightness, okay, we see a difference in the brightness from series and parallel significantly, but even in just a series, this bulb is brighter than this bulb. Okay, but we'll talk about what the brightness means and everything else later. Right now, back to loop and junction. So loop has to do with the idea of any loop. So I could talk about one loop here, that loop, or that loop. I could talk about just the one loop here. The loop rule states that the total voltage in a loop has to be 0. So if I add up all the voltages, it has to be 0. So let's explain what I mean. So I'm going to put the red lead here on the positive end of the wire, of the battery. How do I know it's a positive end? Electrons are going into that. That's why it's positive. Okay, positives attract negatives. And so I know that's a positive end. So I'm going to use red with positive all the time. So when I connect here, I see I have a 9-volt battery. Alright, so now I'm going to disconnect. I'm going to go into the light bulb. So I want to put red on positive. Electrons are coming in here. I put it there. And we get negative 1.5. So we had 9 volts, positive 9 volts here, negative 1.5 volts here. Realistically, it should be negative because the light bulbs are using energy. The battery is positive because we're supplying energy. So, alright, so let's disconnect. Now I'm going to put the red one on the positive end of the next light bulb. Black goes to the negative end. And again, I know this is the positive end because the electrons are coming in. Now I get negative 3 volts. Alright, now let's try one more. So I'm going to put the red on the positive end where the electrons are going in. And we get negative 4.5. So think about this. We had positive 9 here. We had negative 1.5, negative 3, negative 4.5. If you add up those four numbers, you get 0. We could also do that even in the parallel circuit. So if I come up here to the positive, I'm going to put a red on the positive, just like we talked about. Black on the negative. We have a 9-volt battery. Now if I go to this circuit here, okay, I'm going to put black on the negative. I want to put the red on the positive. And I get negative 9 volts. So positive 9 volts, negative 9 volts. In this loop, that works. Okay. If I were to put it down to this one instead, negative 9 volts, and so on. So any loop, that's going to work. So that is your basic loop rule. Let's talk about the junction rule. Now there are no junctions here. A junction means that there's basically places where the current can split. And this one's pretty simple too. If I put this ammeter right before the split, it says there's 1.65 amps. If I put it after that split, it says 0.75. 1.65 and then 0.75. If I put it here, it says 0.9 amps. Well, 1.65 equals 0.9 plus 0.75. That's it. That's the idea of the junction rule. The total current going into any point has to equal the total current going out of that point. And I can apply that here. So let's talk about this junction. So going into it, we see 0.75 amps. Over here is 0.45. Over here is 0.3. So 0.75 equals 0.45 plus 0.3. That is true. It works on the other side of the circuit too. So going into this point is 0.3 going into this point is 0.45. Coming out of this point is 0.75. 0.3 plus 0.45 is 0.75. Now talk about this point. The 0.75 is going in. I see electrons going in over there, so I have 0.9 going in. 0.9 and 0.75 is 1.65. So that is the junction rule. So you're just going to try a couple little examples of that today and see how we do mathematically with it. Give it a try and we'll talk more about it next time. And of course, let me know if you have any questions.